Hi, welcome to my talk, The Domain Functions Architecture, Building an Entire Streaming App by Writing Two Functions. My name is Bobby Calderwood. I'm the founder of evidencestack.com and longtime distributed systems and event-driven architecture proponent. That's what my company does. Before this, I was a distinguished engineer at Capital One on the technology fellows team there at Capital One. Before that, I was at Cognitect working on a database called Atomic and on the language Clojure and ClojureScript. And yeah, as I said, I'm an enthusiastic advocate for event-driven architecture, event streaming. I was selected this last year as a Confluent Community Catalyst and about to release a training course on event modeling and domain functions, kind of the subject matter of this talk. So look for that training course to be released soon. It'll go much more in depth into a lot of this subject matter that we'll discuss today. I am a relative newcomer to the Solus ecosystem, eager to learn. I've been looking at the technology over the past few months, really interesting stuff. So yeah, if you have any questions at the end for Solus in particular, I will be not able to answer them, but eager to learn. And one thing you might not know about me is that I just coined the term domain functions architecture like a couple of months ago. So this is not a thing that you missed. Like, this is a thing that I made up in my own head. But this is some that name, domain functions architecture, really encapsulates and captures a lot of the work that I've done in my career, a lot of the thinking that I've been doing around event-based architecture. And it really simplifies a lot of things. It makes things a lot easier to reason about, a lot easier to implement as code. So I hope you find it helpful. What kind of problem are we talking about solving here? We're not writing compilers, we're not writing video games, right? This is a very specific type of software system. It's really a business information system. It's about automating a business process. It's about trying to bring some order to the chaos of these business processes, and in particular, those processes that we expose as apps and services to our internal users, to our customers. A lot of these types of systems are long running, like these business processes run longer than computer processes and clock times on a machine. We're talking about things that last days and weeks. And so we store these data in order to sort of process these transactions. We have to store data, and we need to think about how that state changes over time. And that's really the most important thing about this category of system that we'll be discussing today. It's probably the kind of system you write. So this should be familiar to you. We think about these as apps and services or enterprise software or whatever. That's the kind of category of system that we're talking about. One of the things about this system is usually we're talking about transaction processing, like this is app development, more so than building data products. But one of the iron laws that I've learned in my career over the past little while is that when you capture data in your application or you generate data from your applications that you write, somebody else in your organization, or maybe someone else on the internet, wants that data, right? They can't stay locked up in that, in your database. It can't stay, just doing the transaction processing concerns. People downstream want this data, right? Auditing, marketing, operations, to integrate with other systems and, kind of trigger events happening in other systems. And then, of course, to build data analytics, to train machine learning models, to do all the cool stuff that you want to do with data in 2023, you need to be able to get at this data, right? So writing apps that just sort of live in your database and you can myopically focus on your business domain and block out everyone else, those days are gone, right? That's why we talk about PubSub. That's why we talk about event-driven, is because we're trying to unlock the data from out of our transaction processing context and get it out into the broad organization. So for example, we've got this system that we'll talk about kind of throughout the talk. It's an autonomous vehicle ride-sharing app. Imagine you own this really cool self-driving car and you drive to work, or it drives you to work. And then you don't want it to just bake in the hot sun in the parking lot for 8 hours, right? You want it to go make you some money. So it can go out, you make that car available. It drives itself around in a creepy way. And riders can request rides, kind of like a ride-sharing app that you might be used to. And then the car will pick them up, take them to the destination, drop them off. Then at the end of the day, you can say, hey, I want my car back, please, so that I can drive home. And it'll return your car and you can be off to the races. So that's kind of the app. That's the system that we'll be talking about today. Hopefully that's relevant, applicable to the types of apps and services that you write. It's got some nice characteristics that that will highlight some of the aspects of this architecture that make it easy to implement using the domain functions architecture. So we're going to break down that term that I coined a couple of months ago, the domain functions architecture, like it's a 2000 marketing slogan, right? In the early 2000s, it seems like everyone had all that. I worked for like 3 companies in a row that had like word, period, word, period, word, period. We're going to do that. So domain functions architecture, all right? I would have gotten a raise in 2007. So what is a domain? The dictionary definition, it's sort of a specified sphere of activity or of knowledge, pretty broad, right? Sort of generically, when you talk about computer system design, software system design, it's a grouping of concepts within a boundary. And this just helps us sort of like shrink the problem that we're trying to solve, from the universe down to something sort of tractable, right? We're going to sort of take subsets of subsets of subsets until we can just talk about, okay, this is just what we're talking about. This one set of things right here. Again, some of the functional programming people go crazy here with category theories and types and all kinds of stuff. Not especially useful, I don't think. Sometimes it's fuzzy. You can't really tell where the boundaries are of these domains. In domain-driven design, there's sort of a discipline of software design called domain-driven. And domain-driven design is all about trying to design software, keeping in mind sort of the natural contours of the business domain. Here's the business problem that we're trying to solve. Let's make our software resemble the business problem instead of getting the business people to try to explain it in terms that our software is used to thinking, right? Let's meet the business where they are instead of forcing them to think like the silicon, right? So DDD, short for domain-driven design. Domain is encapsulated in a model using a bounded context. So you draw a model of something and then you sort of draw a circle around it, and that's my bounded context. That's the thing I'm talking about, not this other thing outside of this boundary, just this here. But how you delineate that boundary around your context is a little bit fuzzy, right? Sometimes we talk about it linguistically in terms of words that people use, this ubiquitous language that people talk about. A lot of times it's just sort of a gut feeling, kind of intuition, or you sort of look at your existing organizational or system boundaries and kind of, put your thumb in the air and try to figure out where the boundaries are. None of these are like really especially helpful to me. As I got into event-based system design, dabbled in domain-driven design. So I don't want to have a PhD in linguistics to try to figure out how to write a system, right? I just want to write it. So the most useful guide that I found to building this type of system is narrative, right? Causality, stories, right? Our brains are wired for stories. That's just how our brains work, right? We naturally infer causality from a narrative or a sequence of events, and we tie them together, even spuriously sometimes, even if they don't actually affect each other causally. We try to make sense of the world by reasoning about the story. This thing happened, and then this thing happened, therefore this thing happened, and so this other thing might happen in the future, right? So we try to predict what happens next. So our brains are naturally wired this way. Fortunately, business processes are repeatable and describable as a story, right? This is almost certainly how your business subject matter experts in your organization think about their business processes in which they are expert, right? They think about it like a story. Well, the customer comes in and then they do this, and then they ask us for this, and then we give them this, and then they go on their way, right? That's how people think about these business processes, as a story. So rather than trying to reason about nouns and language and linguistics, let's think about stories, right? So, and the other thing to get out of your mind is kind of all the software stuff. Get all the database stuff out of your head, get all of the software concerns out of your head, and begin understanding the problem the way that your experts do, your business subject matter experts, as a story. And you tell that story, and the sort of top level story, the big story, for a particular organization or maybe a business process or something. That's kind of the parent domain. That's what we're talking about, right? Autonomous vehicle ride sharing. That's the parent domain. Each plot point kind of along this narrative, the story that I told you kind of at the beginning of the talk, where I described kind of the use case for this application, each of those little plot points, that's a business event, right? I have a car, I make that car available, a rider requests a ride, that ride gets scheduled, the rider gets picked up, rider gets dropped off, I ask for my car back at the end of the day. Those are the events. They're just natural. They came out as I told that story and described that application use case to you. Those events were in there. And then usually within sort of a parent domain, you'll have kind of mostly independent plot lines, right? In a movie, you'll often have 2 or 3 different plot lines, kind of the main plot line, and then 2 or 3 sort of subplot lines. These are more or less independent. They kind of affect each other in very specific ways, but more or less, these are independent stories, right? In our application, we've got, a couple different stories in there happening, which we'll talk about here in a second. So really what we want to think about when we're talking about a domain, let's think about a story. Let's think about a narrative. Event modeling is a modeling technique that really, really helps to visualize this, make our stories visual like we do in the movies or in plays or whatever. Making it visual really helps our brain process these things. And event modeling is a great technique for doing that. This talk isn't about event modeling. I'm not going to talk about how to do it. But what I'm showing you here, this is an event model of the application that I described. This is our autonomous vehicle ride sharing application. You see at the top, there's some kind of interfaces, user interfaces that the user is going to touch and feel. Along the bottom here, there's orange sticky notes that represent those major plot points. Those are the events that we want to record so that we understand what's happening in the business process. The blue sticky notes are commands. That's the user telling us, hey, I'd like to change the state of the system in some way, please. The green sticky notes are read models. Those are kind of snapshots of state, like, all right, here's the state of the world right now. Here's the state of your ride. Just got requested, but we haven't scheduled it yet. It's sort of just waiting. It's pending scheduling, right? So interfaces, commands in blue, events in orange, read models in green. It's a very short, completely not sufficient, deep or a rush through of what event modeling is. Don't think that this talk makes you an expert in event modeling. Go check out Adam Dimitruk. Adam Dimitruk invented event modeling. He's got some great resources at eventmodeling.org. And then also I'm releasing a training course on event modeling. So look for that when that comes out on developer.confluent.io. That'll go really in depth into what event modeling is and how to do this domain functions architecture thing. So in our story here, top level domain, autonomous vehicle ride sharing, but then we've got kind of these sub stories. We've got a story about vehicles. This is, I have a vehicle. I'm going to register it with your service. I'm going to make that vehicle available as an owner. I'm going to request it back at the end of the day, right? So we've got something about vehicles. Then we kind of have this other story about rides, right? The life cycle of any particular ride isn't really wrapped up in owners registering their cars and making their cars available, right? Except they both sort of affect this notion of vehicle availability, right? In order to request a ride and have that ride scheduled, there's got to be some vehicles available to me, right? But any particular vehicle's story is sort of orthogonal to the story of a particular ride. So we have sort of two subdomains here within our parent domain. It's not just about the events, all the sort of commands, read models, interfaces that kind of attach to those events by these data flow arrows. They're a part of that domain too. So when we're talking about domain, we probably have a team that's responsible for sort of taking care of the vehicle's story, and then we'll have a team that's responsible for implementing the rides piece of it. Those are separate domains, call them separate bounded contexts sometimes in domain-driven design. Cool. All right, so we covered domains, we got it. What about that word functions? That word can be scary because now I'm thinking about Haskell and math and feeling inferior because I don't know what a monad is, right? There's a lot of sort of good stuff in functional programming. I come from a functional programming background in Clojure. I love functional programming. It's just got a lot of really great ideas in it, but there's some sort of hangups in the industry about it. Like, oh, that's scary. That's for the math people. That's for the PhDs. No, functional programming's just got some really good ideas. And it really boils down to these two ideas that are just killer. The first one is referential transparency, meaning I have a function. The value that I return from that function is only dependent on the arguments that I pass that function. So if I pass the same arguments twice, I should get the same result returned from that function, right? So there's nothing fishy going on. There's no side effects where I'm calling out to some database or looking at a memory location or anything like that. I'm really just, hey, you're asking me about these arguments that you're handing me. I'm doing some math. I'm handing you back the result. That's referential transparency. Immutable data helps with that because instead of banging on a memory location and changing it, I'm going to sort of treat values like a value, and instead of banging on them and mutating them, I'm going to pass them along unchanged, or produce a new value in memory and return that from my function. So that helps maintain referential transparency. And different languages have different techniques for doing this, right? Rust has its own way and Clojure has its own way, right? But a lot of functional programming languages have these two ideas in there. And it turns out these ideas scale to the distributed systems case much better than the idea of objects, right? When we're talking about objects and sort of mutating getters and setters on an object, and then we scale that, maybe that works within your programming language, sort of in your own memory space and process. But as soon as you try to scale that across a wire at the speed of light and start talking to other things, it gets hairy really fast, right? This object-oriented microservices thing that was popular 5 years ago, that's a disaster. Don't do that. Don't do that. Take these ideas from functional programming and build sort of your distributed systems using these ideas: immutable data, just pure functions that produce new values instead of mutating old values. This allows for a sort of a clean separation of pure business logic from side-effecting code. We'll talk sort of extensively about that. And front-end devs have really already embraced this, right? This is how your JavaScript devs are already thinking about this, right? They have reducers, they have Redux, they've got a lot of these techniques that they've borrowed from functional programming and have applied. So there's a lot of probably more familiarity with these techniques now than there was, probably 10 years ago. But you don't need to change languages or adopt functional programming everywhere. That's, you don't need to do that. That's not how this works. This functions thing is really specific. What we're really talking about is 3 functions. The first is called decide. That's all about, users telling me to change the state of something, but I don't know about it yet. We're not going to just do what our users say because they could be incorrect or they could be malicious or they might not be logged in or whatever. So we're going to be careful about this. We're going to take the command, the way that the user is requesting that we change the state. We're going to take the current state of the world, and then we're going to return either an error if they've done something wrong or if we're not sure about it, or if everything looks all right, we're going to return a list of events. We're going to return, all right, based on what you're telling me, here's the next set of things that ought to happen, right? We're not writing these things down. We're not streaming it to some pub sub thing. We're just a pure function, right? Get the command and the current state as arguments, return conditionally a list of events as the result. The next function is called evolve. This is just a reducing function, right? So if you use Redux or if you're familiar with functional programming techniques like fold or left fold or reduce or whatever, this is just a reducing function, right? Take the current state, the next event shows up, now produce me the successor state. What's the next thing that this state needs to be based on the event that just happened? Sometimes this isn't as common. Really, decide and evolve are the kings here. React is sometimes necessary to sort of close the loop and stitch things back together. So if you need to chain events, okay, an event happened, all right, that should cause this command to happen so that we can keep doing things. People call that a saga sometimes in domain-driven design. But this is just a way of sort of chaining things together. So an event shows up, I want to issue some set of commands as a result. Great. So we've covered domain, we've covered functions. Dare we ask, architecture? What do we mean by that? The domain-centric architecture, the domain functions architecture is a domain-centric architecture, very similar to the ports and adapters architecture, or clean, or onion, or hexagonal. There's all these different names for sort of this thing. And one of the really cool ideas that all of these architectures have in common is that they have a functional core and an imperative shell, right? Meaning that sort of the domain logic lives in the middle, and it should be sort of relatively abstracted from the outside stuff. And then you've got the messy world of databases and TCP, IP connections and web requests and all that kind of stuff. And that lives out in the outer shell. We want to sort of, the way that the domain functions architecture is a little different is that we're going to encapsulate our business domain logic and expose that to the outside application using those 3 functions that we just talked about: decide, evolve, and react. We're not going to go into this too much. We talked about this in the course, but we're going to separate the different data types in our system. We've got sort of domain data types. That's where the business logic lives, and that's where we're going to use a compiler to sort of give us some advantage and make sure that we're handling things properly. There's a great book called Domain Modeling Made Functional, which I'll link at the end of the talk, by Scott Washlin, that talks about this. It's really great. And then on the outside, we've got kind of these transfer types. And these are about serialization and storing stuff in databases and transmitting it on the wire and all of that. So we want to separate those two different types because they have different jobs. And the benefit here is that by following this architecture, we can completely abstract away the really messy world of request and response handling and serialization and pub/sub and all this stuff into reusable strategies that are agnostic to the business logic. And you can sort of just plug in arbitrary business logic and that strategy will work for arbitrary business logic. So we'll talk about that a little bit. This is kind of a diagram of the architecture. You know, like a lot of these domain-centric architectures that I mentioned, at the core, you've got this sort of pure domain logic that exposes a functional interface, just these three functions, to the outside application. And you know, that's kind of how this works. And we'll talk about, you know, how this actually functions within an application. So the point of an architecture is to facilitate building, right? We don't make architectures just for our own health or because we think it's fun. The point of an architecture is to facilitate the building of systems. And this is where the domain function architecture plus event modeling really shines. It's very easy to go from event model, which I showed you before, to code, right? For every path from command to event, we're just going to push that through the decide function. This is kind of what that looks like. We've got the decide function here at the top. That's kind of the functional interface that we would expose. That would be a public thing that we'd expose to the outside. Inside, we'd implement this, you know, this is Kotlin, the language. And idiomatic to Kotlin, it might be nice to have an interface that implements this sort of decide thing. So for every command, we're going to implement this decide method, which takes its only argument, the current state. And then we're going to implement that for every command that we have. For each of those, you know, blue cards on our event model, we're just going to have an implementation of that command, right? We're going to say, okay, given the current state of the world, when this command shows up, what do I do? What events should be the next thing that I show? So in this case, the request ride command comes in. We're going to return a list of the ride requested event. And that's it. It's just a list of one thing. It's just, hey, this ride was requested. User is waiting for a ride to come pick them up. Now that event is out there in the world. This ride requested event is written somewhere. Maybe it's on a pub/sub channel. Maybe it's on a Kafka topic. Maybe it's in your event sourcing database. It's there. Now we need to sort of react to that event. Not a react, because that's the name of another function. We need to evolve the current state of our system based on the presence of that event. So we have this evolve function that is really just a reducing function, like I said before. It's very simple. We expose this functional interface to the outside world. Inside, if we're in Kotlin, maybe we want to do this with interfaces and methods. So we just implement this method on the initial ride state, right? This particular event, ride scheduled, really only pertains to a ride that doesn't exist yet, right? The initial ride state. Later, we'll have, you know, a different type, a different domain type that represents a requested ride and a scheduled ride and an in-process ride and a canceled ride and a completed ride. We'll have different types for those. But here, this particular type really only responds to one type of event, right? There's nothing, and then the ride requested event shows up. And so now I'm going to return this requested ride. This is a ride in the requested state. React is unusual, and we won't spend too much time on it, but this is if I need to chain things together to import state from some other foreign domain. I need to import this state. We have this sort of messy situation where when a ride's scheduled, we need to take a vehicle out of circulation. And then when the ride is either canceled or dropped off, we need to put that vehicle back into circulation. That's what the React function is for. So what does this buy us? Why would we do this? Why would we go to all this trouble? The real advantage here, and this is the magic, this is how my company, you know, our team builds all of our apps now, is that we can encapsulate our domain logic, our business logic, the thing that makes our application special, and completely separate that from the strategies for storing data and responding to user requests and all of that kind of application-y stuff. Those things can be completely separate. So we can really build this platform of different strategies one time, and then plug arbitrary business logic into it and end up with different applications. It's really magical. I'll talk about a few ways that we do this. So this notion of strategies in that application, that outer application layer, gives us different options for storing information. We can store information using a traditional state-based storage and retrieval mechanism, right? I look up the state in the database, command comes in, I evaluate that command. We just transiently sort of return these events. We apply that event to the pre-existing state using evolve. We figure out what the next state is, and then we write that down to the database. Or we can use an event sourcing approach where we say, all right, command request comes in. I need to look up all the past events so I can build the state so that I can figure out, so I can run my decide function logic and figure out what the next events are that we're going to write down. We run that, we have these next events, then we write those events down, and then we move on with our lives, right? So instead of this being based on snapshots of state, the state that we're persisting is really just the events. And every time we need to, we produce, here's the current state based on all the prior events that have happened. And then we run our decide logic. So with the same three functions, this decider with decide and evolve, we can either use a state-based approach, or we can use an event sourcing approach. There's lots of different nuances in there with the versioning and all kinds of other different stuff that we can do. But ultimately, the net effect is we can choose how to store data in a variety of different ways. We're not tying our business logic to the specific, database implementations or serialization concerns. Our business logic is separate, and then we can change it and swap it into different databases and different data store technologies as we need to. The other thing that this allows us to do is distribute our business logic in different ways. So we can distribute to mobile apps. We can, run the decide logic on the mobile app, or in the web app, using JavaScript. Or we can say, we don't trust decisions to be made on the client because that could just be someone typing in at the JavaScript console. So we're going to say, hey, we're going to move the decider back to the web service layer, and they're going to send us commands on the wire, and then we'll figure out what to do, what events to write down based on that. Or we can do the new hotness, which is somewhere in between, kind of decider at the edge, right? This isn't all the way back in our web services tier. We're just going to have that decide logic running maybe in a WebAssembly module or a JavaScript module, kind of at the edge in our serverless technology with like Cloudflare pages or Cloudflare workers, and make the decision there, and then just write events back or write states back to our database from the edge. So we've taken that decide logic out of the client, and now it runs at the edge. Still fast, still performant, but it's not suffer from the trust problems that the thick client might. So most importantly, and kind of the bottom line of this talk is that when you separate out your business logic, and then you expose that business logic using this really consistent interface of decide, evolve, and react, you can build your platform of different strategies for storing and persisting and all that once, and then your line of business teams can just be focused in on building those deciders, building the domain logic, right? So you have a platform team that maintains all the strategies, and then the line of business teams are freed up. You don't need PhDs in distributed systems on all of your line of business teams. They can just be focused on writing this domain logic and then plugging that into the strategies. There's some additional resources here that are hopefully will be helpful to you in your journey. Some really great work by Jeremy Chessing, sort of formulating this decider concept. We've in the industry and in the community been talking about this for a long time, but he really put a nice functional programming formulation on the decider. There's the book that I mentioned, Domain Modeling Made Functional. It's really fantastic. Check out Evidence Stack. That's my company. We help teams build apps this way. And check out my course, Practical Event Modeling. That'll be dropping very soon on developer.confluent.io. Thank you, and I'd be happy to answer any questions at this time.